Oh, we started rolling? Hey everyone, I'm Mathematical Matthew.
And I'm Algebraic Alex.
And we're here to show you the awesomeness that is
Graphs! Oh, and transformations too, I guess. But first though, we need to go over the parent graphs.
Oh my god, I know the perfect song.
Really? What? Okay, this is enough of that.
This is y equals 1. As you can see, the y is a constant for y equals 1.
This is y equals x. X and y rise at the same rate, so that's why it's one big straight line, because when y is -1, x is -1, and so on. Shabam.
This is y equals x squared. It is an exponential, as you can see, and that is because it is squared.
This is x cubed. It is again an exponential function, but because it has an odd exponent, it dips into the negative, so that's why it's like that.
This is y equals the square root of x. As you can see, it is also exponential, but it can't be less than 0 because you can't square root a negative.
The cube root of x, it increases and decreases at an exponential rate. And it can be a negative number because there's an odd exponent. Shabam. This is the absolute value of x. It's very similar to y equals x, except for all negative values of x are turned positive. So it becomes a triangle. Shabam.
This is y equals the greatest integer x. Now, this is basically a bunch of piecewise functions of y equals x. It's really confusing and a bit strange, but as long as you know that this is what a greatest integer looks like, that's all you really need to know. Moving on. This is y equals 1 over x. You can tell it's y equals 1 over x graph because of the way it is.
Okay, you're gonna.
Hey!
So the y equals 1 over x graph goes like this and avoids 0, and like this and avoids 0. Because in this case of y equals 1 over x, the asymptote is 0. The asymptote is 0 because you cannot divide a number by 0. So for example, if the graph was y equals 1 over x plus 3, then the asymptote would be -3, and the graph would be shifted over this way, stopping at -3, going down. And the positive side would go all the way to -3 and rise up exponentially.
Hey, you stole my show. Be gone!
There are a bunch of types of transformations, so let's break them down.
When we slide to the left, it means the number in the parentheses is positive. For example, with y equals x plus 3 squared, we slide to the left. Slide to the left. Slide to the left.
And when it's negative, such as in y minus 3 squared, we slide to the right. Slide to the right. Slide to the right. And the graph follows us too.
Neat, right? There's also vertical shifts.
Fascinating. Please, do tell.
I plan to. Okay, so we begin with where the vertical shifts are within a transformation. If you look, dear companion, all vertical shifts are found after the parentheses in the equations, as horizontal shifts are found within them. So if you were to say bring the equation up 3, you would simply add a 3 to the end. If you wanted to bring the graph down 3, you would subtract 3 from the end of the equation. How terribly interesting. Don't you agree, old chap?
You bet it is. I'm bored. Can we go back to being radical?
I thought you'd never ask!
That was really bland. How to make stretches and compressions interesting? Sock puppets!
Hey, Steve!
Hey, Dave!
Do you like graphs?
No!
Well, that's too bad! You're gonna listen anyways! So I love graphs, and today I learned a really cool thing. You wanna guess what it is? Do ya?
Why are we friends?
Well, I learned that if you wanna compress a graph vertically, put a number with an absolute value less than 1 in front of the parentheses. If you wanna stretch the graph vertically, put a number with an absolute value greater than 1 in front of the parentheses.
Please stop.
No! Now shut up! If you want to stretch a graph horizontally, put a number with an absolute value less than 1 in front of the x term in the parentheses. If you want to compress the graph horizontally, put a number with an absolute value greater than 1 in front of the x term.
But wouldn't it be the other way around?
No, because when in the parentheses you compress and stretch by the reciprocal of the number.
Or Are we done?
No, stop asking!
Well, then what are we gonna do?
Stuff!
Stuff? Well, unless you find something else to do, we're moving on.
We're gonna sing!
No! Stop! Please stop! Make it all go away!
Well, if you say so.
Well, they're dead.
Well, is there anything else left to do?
There's only one thing left to cover. Reflections. When the number outside the parentheses is negative, the graph reflects over the x-axis.
But why?
Because everything outside the parentheses affects things vertically, and the x-axis has an up and down. The potential to change things vertically.
But what about when the inside is negative?
Well, I'm glad you asked. When the negative is inside the parentheses, it reflects over the y-axis, since everything in the inside of the parentheses affects things horizontally. I didn't know I had this snapping power until I started this presentation. Check this out.
That's radical, dude.
I know!
Wait, Alex, hold on. Alex, I don't feel so good.
Matt? Matt? I need to go find my co-host. I hope you enjoyed the presentation. Bye. Matt! Where are you?